Imagine a world where machines can learn, adapt, and even make decisions. Welcome to the world of artificial intelligence. This isn't a scene from a science fiction movie, but rather the reality of our present day. At its core, artificial intelligence, or AI, is a multifaceted technology that enables computers to mirror human intelligence. It's like giving machines a mind of their own, one that can analyze data, identify patterns, and make decisions. But it's not just about creating smart machines. It's about augmenting our human capabilities, making us more efficient, more productive, and even more creative. AI has the potential to revolutionize every aspect of our lives, from healthcare and education to transportation and entertainment. It's a game changer, a new frontier that we're only beginning to explore. This is just the tip of the iceberg. The world of AI is vast and constantly evolving. The story of AI starts with a powerful concept: machine learning. Machine learning, at its core, is an algorithm's ability to learn from and make decisions based on data. This technology, which may sound simple, revolutionized the field of computer science when it came onto the scene in the mid-20th century. The earliest form of machine learning, known as supervised learning, involved feeding a computer a large amount of data, along with the correct responses. The computer was then able to identify patterns and make predictions for new data. This was a significant breakthrough, as it meant that computers could learn and adapt without being explicitly programmed to perform specific tasks. The development of machine learning was a game changer, paving the way for more advanced forms of AI. It laid the groundwork for the development of technologies like neural networks and deep learning, which are now at the forefront of AI research and development. Key milestones in the journey of machine learning include the invention of the perceptron in the late 50s, the development of the backpropagation algorithm in the 70s, and the introduction of support vector machines in the 90s. Each of these breakthroughs brought us closer to the AI capabilities we have today. But why is machine learning so important? It's because it's the technology that allows computers to learn from experience. It's the reason why your email can filter out spam, why your phone can recognize your face, and why we can have real-time language translation. In essence, machine learning is the engine that powers AI, enabling it to evolve and improve over time. However, machine learning was not the end of the road in the journey of AI. It was a stepping stone, a foundation upon which more complex and powerful AI technologies were built. With the advent of deep learning and neural networks, AI began to mimic the human brain's function more closely, leading to even more impressive and sophisticated applications. Machine learning was just the beginning, a stepping stone to more advanced forms of AI. Building on the foundations of machine learning, we arrive at deep learning. This is where things start to get serious. Deep learning, an advanced form of machine learning, takes inspiration from the workings of the human brain, specifically how we think, learn, and interpret information. This approach to AI utilizes what we call artificial neural networks, designed to mimic the neural structure of our brains. These networks are formed by interconnected layers of nodes or neurons, each capable of processing data and making independent decisions. This complex web of connections allows a deep learning model to digest vast amounts of data, find patterns, and make predictions, all with minimal human intervention. The evolution from machine learning to deep learning represents a significant leap in our quest to create intelligent machines. While machine learning models require carefully selected features and detailed guidance, deep learning models are, in a sense, self-learning. They can learn directly from raw data, which means they can handle more complex tasks and make more accurate predictions. Think about it this way. Machine learning is like using a map to navigate a city. You're given specific routes to follow. But deep learning? It's like exploring the city on your own, learning the streets, landmarks, and shortcuts as you go. It's a much more organic and intuitive process. Deep learning has been instrumental in some of the most significant advancements in AI. It powers the voice recognition systems in our smartphones, the recommendation algorithms of our favorite streaming services, and even the autonomous vehicles that are set to revolutionize transportation. It's incredible to see how far we've come, from simple rule-based systems to machines that can learn and think on their own. But as amazing as deep learning is, it's just one part of the larger AI picture. It's a crucial stepping stone, paving the way for even more advanced forms of AI. Deep learning marked a significant leap forward, but the journey of AI was far from over. As we'll see in the next scene, the story of AI continues to unfold, pushing the boundaries of what's possible with technology. Neural networks, the game changer in the world of AI. Picture the human brain. It's a complex web of neurons, intricately connected, working together to process information and make decisions. Now imagine replicating that same structure but in a machine. Seems far-fetched, right? Well, that's exactly what neural networks do, and they've revolutionized the field of AI. Neural networks are a subset of machine learning algorithms designed to mimic the human brain. They consist of artificial neurons or nodes which are interconnected just like the neurons in our brain. These artificial neurons are organized into layers: an input layer, one or more hidden layers, and an output layer. Each layer processes information and passes it on to the next, much like a relay race. But what makes neural networks so special? The answer lies in their ability to learn and adapt. Instead of being explicitly programmed, they learn to identify patterns and make decisions based on the data they're fed. This makes them incredibly versatile and powerful. Think about image recognition. Neural networks can analyze thousands of images, learning to identify objects, faces, and even emotions. They can also be used in language processing, where they learn to understand and generate human language. And that's just the tip of the iceberg. Neural networks have also paved the way for deep learning, a more advanced subset of machine learning. In deep learning, neural networks are stacked together to form deep neural networks, which can process even more complex data sets. This has opened up a world of possibilities, from self-driving cars to virtual assistants that can understand and respond to natural language. But perhaps the most significant change brought about by neural networks is how they've transformed our understanding of AI. They've shown us that machines can learn, adapt, and even think in a manner of speaking. This has shifted the paradigm from AI as a tool to AI as an evolving, learning entity. Neural networks opened up a world of possibilities, setting the stage for even more advanced AI technologies. Imagine if machines could understand and respond to human language. Welcome to natural language processing. As we dive into this fascinating world, we see the crux of a technology that has revolutionized the way we interact with machines. Natural language processing, or NLP, is the technology that enables machines to understand, interpret, and generate human language. It's the magic behind your digital assistants understanding your voice commands, search engines delivering relevant results, and even your email filters keeping those pesky spam messages at bay. This technology started with simple rule-based systems where computers were programmed with specific rules to understand language. But, as we know, language is complex and nuanced, filled with idioms, slang, and cultural references, so the rule-based approach had its limitations. Enter machine learning. It allowed computers to learn from vast amounts of data, making NLP more flexible and adaptable. Deep learning further refined this, enabling machines to understand the context, sentiment, and even sarcasm in language. But why is NLP so significant? Well, it's the bridge that connects us, humans, with the AI world. It makes AI more user-friendly, interactive, and intuitive. It's the driving force behind voice-activated home assistants, real-time translation apps, and sentiment analysis in social media. But it's not just about making our lives easier. NLP also plays a vital role in critical areas like healthcare, where it helps in analyzing patient records, or in law enforcement, where it assists in crime prediction by analyzing patterns in data. NLP is still evolving, with researchers around the world working to make it more accurate and comprehensive. The goal? To create AI that can not only understand language, but also comprehend the subtleties and nuances that make human communication unique and rich. Natural language processing brought AI closer to us, making it a part of our everyday lives. It's the powerhouse that turned the idea of conversing with machines from science fiction into a daily reality, and this is just the beginning. The future of AI is here. Reinforcement learning. This form of AI is a game changer, as it enables machines to learn from their own experiences. Imagine a robot that learns how to navigate a maze, not by being programmed with a specific path, but by trying different routes, making mistakes, and learning from those mistakes. That's reinforcement learning for you. In essence, it's about trial and error, reward, and penalty. When a machine makes a move that brings it closer to its goal, it gets a virtual pat on the back, encouraging it to repeat the action in the future. Conversely, a wrong move results in a penalty, discouraging repetition. This technology is the next big step in AI, pushing the boundaries of what machines can do. It's the key to creating AI that can adapt to new situations and evolve over time without needing explicit instructions. Reinforcement learning represents the future of AI, a future where machines can learn, adapt, and evolve on their own.